Hey, what is up guys? Welcome back to another video, and in this video we're going to be continuing on with our Swift programming tutorial series. And in this particular tutorial we are going to be talking about how we can apply constraints to generic type parameters so we can limit what kinds of objects that we can use with our generic type parameters without sacrificing type safety and reusability. All right, so you can see here I have a class called animal. This animal class goes and conforms to a custom protocol that I created called printable. Now, this protocol has a method of print information. So we have an implementation of that method in animal. This animal class has two string properties, type and country of origin, for describing what kind of animal it is and where it's from. This will do just fine for the example we're going to go with today. Inside of print information, we are printing the type of the animal and the country or countries it's from, separated by a comma. Pretty simple setup, okay? Now, if we go into our main file, now inside of our main file, what we can do is we'll create an object for type animal. So we can say var and here we can say monkey equals animal. We want monkey, and for country of origin we want to have Africa and Asia. All right. Perfect. And we could just do monkey dot print information, save and run it, and that will work just fine. However, what if we have many objects and what if we have many objects that conform to printable, and we want each of them to have their own implementation of print information, but we don't want our method to have an overload for every single one of those classes that conform to printable. Well, that's where generic constraints come in, where we can have a method that takes a generic type parameter, and we can have it require that any type passed to the function as a parameter, for instance, must conform to a specific protocol or inherit from a specific class. All right, so we can do this. Here we want to say, instead of saying monkey.print information, we can go ahead and say func, let's say print information, and this will take a generic type T. And in order to apply a constraint after our generic type, but before our greater than, we can say colon printable greater than object T. And we can say object dot print print information. So let's go over what exactly this is doing. So we have a function called print information, separate from the method inside of our protocol or in our animal class. And this is a generic method that requires that T, our generic type, conform to the printable protocol. And we're passing it an object of type T. So this is telling the developer that the consumer of this method, hey, the object you give me must conform to the printable protocol. And because we have that constraint, we are able to call the print information implementation of whatever object is passed to the method. So let's go ahead and say print information. In the autocomplete, you can see that we have void, okay, print information, and it takes in a printable. That's because our generic type must conform to printable. So we'll say animal. Go ahead and save that, run it. We get a build failed. Let's take a look at what we got. Cannot find animal in scope. Okay. That's because it's not called animal. It's monkey. That's what it is. Save that, run it. Now we have our build succeeded, and we get the same output as we did last time, but this time the code is much more reusable, uses that generic constraint. Now, what will happen, do you think? All right. Let's see. What do you think will happen if we try to pass it something like an int or a string? We can say print information, and we'll try to pass it, say, an integer of 1, 2, 3, 4. We can save this, and we get an error inside of Xcode. We can see that it's telling us, hey, you gave me an integer, but int, the structure of int for the data type, doesn't conform to printable. So in order to give me that integer, you must have int conform to printable, which it does not at the moment. If you really wanted it to, you could create an extension to have it conform to printable, and then it would work. But in this particular example, you might not want to do that. There are other examples where you might want to do that. Now, when it comes to generic constraints, I want to share with you another example of where this is often used, and that is with network requests. Okay, like I mentioned in the beginning, I use the constraints a lot when I'm doing network requests, because generally speaking, when I'm doing my network requests for different endpoints, they're almost never different in terms of like headers and stuff like that. You do not have to understand any of that for this explanation, but just know that when I have network request methods, they're generally using a generic constraint. Now, what exactly do I use for that then, the constraint? Well, I always have I always have them either constrained to conform to codable, so the generic object that it returns or takes in must conform to codable, or I'll have it be just decodable or just encodable, because with network requests you're going to receive data like JSON back, and you want to parse that, and in order to do that, your objects and stuff must conform to codable, decodable, or encodable. So applying that constraint to a generic method helps a lot with doing that, so I don't have to have overloads of the same method just with different object types. That pretty much does it for this video on generic constraints in Swift. Thank you all so very much for watching, and we'll see you in the next one.